Hi, today we will be explaining how to convert binary to decimal, hexadecimal to decimal, and decimal to hexadecimal, decimal to binary, binary to hexadecimal, and hexadecimal to binary. Okay. Binary is in base 2, from 0 to 1. Decimal is in base 10, from 0 to 9, and hexadecimal is in base 16, from 0 to F. Binary is used to represent sound and video. For example, CDs, DVDs, and Blu-rays use it to represent sound and video said. Decimal is a familiar base for everyday calculations. These conversions facilitate communication between different systems and programming languages, ensuring compatibility and data integrity. They are fundamental skills for programmers, network engineers, and anyone working with digital data. In a world dominated by technology, mastering these conversions is crucial for understanding, troubleshooting, and innovating within the digital realm. As said, binary is a simplification of hexadecimal, making it more easy. Okay, binary. Binary, as said, is a base 2 number system invented by Gottfried Leibniz that's made up of only two numbers or digits, zeros and ones. This number system is the basis for all binary code, which writes digital data such as the computer processor, instructions used with your device every day. We will show you how to convert from binary to decimal and decimal to binary. Let's start. Okay, first we need to understand that binary is read from right to left. So you start reading from the most right and end in the most left. Okay. Firstly, depending on the position, you start with 2 to the power 0 because it's in the most right. The next one is 2 to the power of 1. The next one, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7, and following. So this is a pattern where we see that from the most right, you start from 2 to the power of 0, and if there is 8 digits, the last one will be 2 to the power of 8. Okay. So if you want to convert from binary to decimal, you need to understand that 2, for example, you have here a 1, and it's in the most right. So that will be 2 to the power of 0, as said, times 1, because there's a 1. If there was a 0, it will be times 0. And that will represent 1 if there's a 1, and 0 if there's a 0. Because it's 2 to the power of 0 times 1 or 0. Okay, we have this number, let's do it. We have 2 to the power of 0 times 1, because there's a 1, plus, important thing, we need to add them, 2 to the power of 1 times 0, but it's times 0, so it will be, you are adding 0. But for example, this one has a 1, so it will be 2 to the power of 2 times 1, that will be 4. The next one, we also have a 1, so it will be 2 to the power of 3 times 1. So we have 2 to the power of 3 plus 1 times 1, that will be 8, plus 2 to the power of 2 times 1, that will be 4, so 8 plus 4, 12, plus 2 to the power of 0 times 1, that will be 1, 13, plus 2 to the power of 5 times 1. That will give you 32. So you will do 32 plus 8 plus 4 plus 1. That will give you 47. So this number will be 47. Only that it's written in binary code. If we had a 1 here, it will be 2 to the power of 7 times 1 plus all of this. But there's no 1, so we don't need to do it. Next thing, how to do from decimal to binary. This is a more complex, but it's not really more difficult. Okay, let's say we want to convert 56 to binary. Let's start. 56, we need to start dividing it by 2. So we will do 56 divided by 2. 28. There's no remainder. It's an even number, so there's no remainder. So we write 0 as the remainder. 28 divided by 2. We are getting the 28 from here, and we are dividing by 2. 14, there's no remainder, because 28 is an even number. Okay, now we do 14 divided by 2. 7, there's no remainder, because 14 is an even number. But now we do 7 divided by 2. Okay, this is 3.5. 3.5 has a remainder, that will be 0.5. And we need to do 0.5 times 2. How much will that give you? 1. So you write 1. Okay, now we get the 3 because we don't want remainders in this side. This side, no remainders. So 3 divided by 2, 1.5. 0.5 is another remainder, so we do 0.5 times 2. So it's 1, we write the 1. These are the remainders. Let's say it's 1. Okay, now we get the 1, and we do 1 divided by 2. 0.5, okay. So once we have 0 here, in this side, we need to stop, okay? And we have 0.5, so it's 0.5, the remainder, times 2, that will be 1. Okay, so we have the remainders, all of these are 1, 1, 1, 0, 0, 0. We write them down. As we have written this, we write them down, okay? And now we have to read them from down to top. And that will be our binary number. So 56 in binary will be 1, 1, 1, 0, 0, 0. Hexadecimal. Hexadecimal, as we have said, it's a base 16 number way of counting, and the important thing is that we can do binaries much simpler with the hexadecimal because we can do them in group of 4 bits. Every 4 binary numbers, ones and zeros, every 4, that's 4 bits. Okay, 1 bit is 1 0 or 1 1. Okay, the notation for hexadecimal is from 0 to 9, but we need 5 more numbers because it's base 16, so we need to use A's, B's, C's, D's, E, F's. From now on, these will be numbers for us. A will be equal to 10, B to 11, C to 12, D to 13, E to 14, and F to 15. Okay. So how do we convert from hexadecimal to decimal? Okay, let's start. Like before, in binary, depending of the place of the number, it will have 16 to the power of 0, or 16 to the power of 1, 16 to the power of 2, 16 to the power of 3, etc. So the most right will be 0. The next one, 1. Next one, 2. Next 3. Next 4. Okay. So how do we calculate this into decimal? Okay. So we do 16 to the power of 0 because it's in the most right, and we're working in base 16, times 3. Before we did times 1 and 0, but it's because it's binary. But now we are doing hexadecimal, and we're doing times 3. So we're doing 16 to the power 0 times 3. That will give us 1 times 3, 3. And then we need to add, because we're always adding. Like in binary, we are adding. Now we are adding. Okay, and now we're doing A. We need to know what A is equal to. A is equal to 16 to the power of 1 times A. But what was A? It was 10. It was 10. It's not that difficult. It's just 10. So it's 16 times 10, 160. And we are adding. What are we adding next? 16 to the power of 2, because it's in the third one, times 1, because this is a 1. So that will give us 16 to the power of 2 plus 16 times 10 plus 1 times 3. That will give us 419. And how do we do decimal to hexadecimal? Well, it's funny because it's really similar to doing decimal to binary. So it's really easy. Okay, we do. Let's say we want to do from 560 to hexadecimal. 560, we need to divide by 16. Before we did between 2 because there were two digits, 2 units, and now we're doing 16 because it's base 16. Okay, 560 divided by 16. 35. The remainder, 0. There's no remainder. 560 divided by 16. Okay, now we do 35 divided by 16. Well, we get 2.1875. Okay, as before, we do 0.1875 times 16. So we write down 3 because it's 3. And now we get the 2, and we do 2 divided by 16, 0.125. Or we stop because there's already a 0 in this part. And when there's a 0, we need to stop. And we do 0.125 times 16. That will be equal to 2. Okay, so the remainder is 2. Now we write down the remainders in the order we got them: 0, 3, and 2. Okay, 0, 3, and 2. And we need to make sure that they are in hexadecimal, because right now these are normal numbers. In this example, there's no problem because we didn't get any 15, 14. But if we had, for example, a 10, that would be equal to A. So if we had 10 here, we write A. Okay, so we write it down in hexadecimal. This will be hexadecimal already. And we do from down to up, and we write it 2, 3, 0. That will be the number hexadecimal in base 16. So in base 16, 560 is 230. Okay, now I want you guys to practice. I have put up here 16 to the power of 0 equals to 1. To put 1, and 16 to the power of 2 equals to 256, and 16 to the power of 3 equals to 4096. I want you to practice. Stop. Now. Okay, now we're going to do binary to hexadecimal. This is the most easy thing we're going to do now. Really easy, okay? Trust me, guys. We have here 12 ones and zeros, okay? For binary to hexadecimal, we need to divide the binary in groups of 4, from here to here. Groups of 4, okay? So we do 1, 1, 1, 0. That will be a group of 4. 1, 0, 1, 0. That will be another group of 4. And then we do 1, 0, 1, 1. That's another group. We divide them, okay? And the next thing we need to do is, okay, we have 0, 1, 1, 1. We know how to do binary to decimal, so we need to do binary to decimal. That will be 2 to the power of 0 times 1, 2 to the power of 1 times 1, 2 to the power of 2 times 1, 2 to the power of 3 times 0, because there's a 0, as we said before, and it will be equals to 7. 7 in hexadecimal is 7, okay? But we need to make sure we have it in hexadecimal always, because if we get 12, 12 in hexadecimal is not 12, it's C. Okay, now we do it for this one. This one will give us in decimal 5, and in hexadecimal 5 is 5. And here we get 13, okay? And 13, we already know that in hexadecimal is D. So our final number is D57. D57. Wow! Next thing. How do we do hexadecimal to binary? Well, it's really easy. Don't get scared, okay? Look, we know how to do binary to decimal, okay? We know how to do hexadecimal to decimal. Then we just get, look, we have BA7. This is a hexadecimal number. We get the 7. The 7 in decimal is 7, okay? So how is 7 in binary? 0, 1, 1, 1. And we can calculate that before, as we did before. Okay, and now we do A. How do we write down A hexadecimal in decimal? It's 10, okay? And how do we write 10 in binary? 1, 0, 1, 0. Okay, and now B. How do we write B in decimal? It's 11. And how do we write 11 in binary? 1, 0, 1, 1. And now we just need to aggregate them. Okay, we don't need to add the ones and 0 because it's in binary. We just need to aggregate, so we won't get 1, 0, 1, 1, 1, 0, 1, 0, 0, 1, 1, 1 will be our binary number. Okay, here we have some problems. I want you guys to solve it, okay? Put this number in binary. Put this binary in hexadecimal. This binary in hexadecimal, and this hexadecimal in binary. Okay, so a quick summary of everything we have learned. From decimal to hexadecimal, we divide it by 16, and the remainders, we write them down, and from down to top. Hexadecimal to decimal. From hexadecimal to decimal, we just need to get 16 to the power of n, because depending if it's in the right, the most right will be n equals to 0, and progressively, as you are increasing, that will get bigger, n will get bigger 1 per 1. And we need to multiply it by 1 to f. That will be, for example, if we get a, we need to do 1 times 16n, depending on where's the a. If it's in the first position, will be 1 times a, that will be a is 10, so it's 1 times 10. And we need to make sure we are adding them, if there's more than one unit. Okay, from decimal to binary, as we said, we need to divide by 2, and write down the remainder, and from down to top, from down to top, we write it down. Binary to decimal, okay. From binary to decimal, we need to do 2 to the power of n. If it's in the most right, then n is equals to 0, and you add 1, 1, 1, 1, 1, and so on, and you multiply it by 1 or 0. If you get 1, you are multiplying by 1, because if there is a 1, you are multiplying by 1. Okay, let's say we have 0, 1. If we have 0, 1, then it will be 2 to the power of 0 times 1, that will be 1, plus, because we need to make sure we are adding them, 2 to the power of 1 times 0, that will give 0. So 0, 1 will give you 1. Hexadecimal to binary. Hexadecimal to binary, we get each one, its number independently, and we find it in binary and we just aggregate, as we said. And binary to hexadecimal, we need to do sets of 4 and find the number in base 16. For example, 1011, that's a group of 4, and we need to calculate it in decimal first. That will give you 11, and you need to write 11 in base 16. That will be B. Thank you so much for listening, and I hope you understood. If you didn't understand, you can do any question. Thank you.